Hello everyone and welcome to my channel, and in today's video we are going to solve one more LeetCode question, that is 74, search a 2D matrix. So in this question we are provided with a m cross n integer matrix with the following two properties, that is each row in the matrix is sorted in non-decreasing order and the first integer of each row is greater than the last integer of the previous row, and we have to find a target value which is given to us, and if the target value is existing in the 2D matrix then we will be returning true, else we will be returning false. So this is the question, and I don't think so that this question is complex in any sense, because we all know that if a target value is given, so we will traverse through this whole matrix and we will search for this target value and we will return true if the value is existing. But there are two downfalls if you are going to solve this question using this approach. First thing is that suppose if the target value is 90, so in this case I will be traversing this whole matrix and the time complexity will be around big O of m cross n, and after traveling through this whole matrix at the end I will realize that the target value is not in our 2D matrix and I will be returning false. So this is the one thing, that I will be traversing this whole matrix even when the target value is not existing. And second thing is, in the problem statement it is given to us that the data in the matrix is sorted, but we are not utilizing it to just cut off our complexity and optimize our solution. So that is second downfall, that we are not using the given properties. So again, if we are going to revise the given problem statement, if we are going to check the problem statements again, we will be able to understand what the question is exactly demanding for. So if we are going to check this question, the first property is that each row is sorted. So our input data is in sorted order. This is the first point. Second point is, we are given an integer target and we have to search for that target in the sorted data. So first point was we are having sorted input, and second point is we have to find or search a value in that sorted data. And third and the most clear point is that we have to write a solution which is going to be of log of m cross n time complexity. And we know that these 3 points where the data is sorted and we have to find something, like we have to search a target, and we have to search a target in that sorted data, and the time complexity has to be in terms of logs. All these 3 points, these 3 properties are already present in our most famous lovely algorithm, that is binary search. So we are going to solve this question using binary search, but it is not going to be that straightforward where we are going to apply the binary search right away on this 2D matrix, because there are two things that we need to find in this question. First thing is, we have to find the potential row in which our target value might be present, and after finding that row we have to search for that target value in that row. So firstly we will apply binary search on this 2D matrix and find our potential row, and after finding that row we will again apply binary search on that row so that we can find the target value. In this manner, firstly when we will be applying the binary search on row, so the time complexity will be big O of log m, and when we will be applying binary search next time for the target value, the time complexity will be big O of log n, and we all know that log of m plus log of n is equivalent to log of m dot n. So our time complexity will be big O of log mn. So this will be the whole approach. Now I hope the approach is clear to you all. So let's jump to the coding part. So as we already discussed before, firstly we will be applying binary search for finding out the potential row. So for that we will firstly define our left and right pointer. So left will be 0, right will be length of matrix minus 1. And after this what we will be doing, we will be applying a while loop where while L is less than equivalent to R, we will run this loop. Firstly, we will be calculating the mid value, the usual binary search, that is left plus right divided by 2. After finding the mid value, what we are saying, if our target is greater than our matrix in that row. So what I'm saying, my target value is greater than the last value of this row. So what I'm saying is, suppose my mid value is 0, right? My mid value is 0 and my mid value is 0, so this will be the row. And in this row, if I'm saying my target value is 3, so if my 3 is lesser than this value, the last value of this row, then what I will be doing, I will be applying binary search on this row. Or else, if my target value is greater than the last value of this row, suppose my target value is 16, then what I will be doing, I will be shifting my left pointer towards this by mid plus 1, right? Then I will be searching towards right direction, towards down direction, because we know that the data is sorted. And if my target value is greater than the last value of the row, then I will be searching in the right direction. But if my target value is lesser than the first value of this row, then what I will be doing, I will be searching in the upward direction. Okay, so what we will be doing, we will be comparing our target values with the last value to move our left pointer. And if we want to move our right pointer, then what we will be doing, we will be comparing the values with the first element of each row. So this is what we are doing. So this is what I'm doing. I'm saying if my target value is greater than the last value, then what I'm saying, update my left pointer by mid plus 1. And if this is not the case, and my target value is lesser than the matrix mid 0, right, the first value, then what I'm saying, update my right pointer now. In this case, update my right pointer. And if this is not the case, then simply break. This means we have already reached a condition. After this, what I'm saying, if left is less than equivalent to right, if left is less than equivalent to right, and if this condition is not true, what I will do, I will return false. This condition is just checking that after getting out of this loop, our left and right are eligible for the further search. Because if this condition is true, where our left is greater than the right, that means there is no row in which our target value is existing. So this is one of the edge cases for which I added this condition. And if this is false, what we are going to do, we are going to apply the binary search on that row, right? We are going to apply binary search on this row that we calculated, and again we will do the same thing. Left is 0, right is this time length of matrix 0, column length. And after this, again same thing, while left is less than equivalent to right, and if this is true, what I'm going to do, I will calculate mid value, that is left plus right divided by 2. And again I will check if the target value is greater than the matrix row M. If this is true, then update my left pointer by mid plus 1. And if this is not true, check if target value is less than matrix row M, and update my right pointer with mid plus 1. And if these two conditions are not true, then definitely I have reached a condition where my value is equivalent to target, and in that case simply return true. And if somehow we step out of this loop with no answer, then we will return false. So this was the whole code. Let's see if I hadn't made any mistake, this will run properly. Oh, I had done one mistake, and that is when we are updating right pointer, it is not going to be m plus 1, it is going to be m minus 1, right? Because we'll be shifting towards left, right? So this is one mistake that I did. I still return true. I had done 3 typos in this code, so please correct it. Okay, so this question is submitted, and we can see this is quite efficient. This question is quite easy, and I would say I really like this question because it is kind of pretty straightforward, where the hints are clear, the properties are clear, and we can easily reach toward to the optimal solution with all these hints. So I hope this whole question is clear to you all, and you really find this whole explanation useful. And if that's the case, then don't forget to like this video, subscribe my channel, because that's the only motivation. And I will be soon coming up with few more questions. Till then, keep watching, keep coding, and thanks for watching.